So this video is about special right triangles, in particular 45-45-90 triangles and 30-60-90 triangles. What I mean by 45-45-90 is you've got two 45 degrees and a 90, which that's 90 plus 90, so 180. And a 30-60-90 is 30 plus 60, which is 90 plus 90, so again 180. These pop up quite often, and they have some special relationships with their sides. So that's what we're going to talk about today. You can always use trig or sometimes even Pythagorean theorem to solve for these sides, but these are just kind of some shortcuts. Before we get going today, go ahead and pause the video and try these. Okay, so hopefully you've tried them. I'm going to work through them here. So if a square has side length 1, that means this is 1, this is 1. I want to find the length of the diagonal. Again, this would just be Pythagorean theorem. 1 squared plus 1 squared equals the diagonal squared. So it would be 1 squared plus 1 squared and then square root it, which would be 1 plus 1 is 2, so the square root of 2. So if a square has side length 1, then the length of the diagonal is square root of 2. All right, let's try another one. If the square has side length 2, so like 2 and 2, what's the length of the diagonal? Again, just do Pythagorean theorem, but it would be 2 squared plus 2 squared. 4 plus 4 is 8, so square root of 8. And I can actually simplify square root of 8. It breaks into square root of 4 and square root of 2. I'm just breaking up 8 into 4 and 2. And the square root of 4 is 2. So 2 root of 2 is the length of this diagonal. Let's see if it has side length 3, what happens. I'm going to erase this. So this one was 1 root of 2, this was 2 root of 2. If it has side length 3 and 3, then this diagonal would be 3 squared plus 3 squared, and we'd square root it. That's 9 plus 9, so 18. 18 can actually break into 9 and 2, and the square root of 9 is 3, so 3 root of 2. So this diagonal here is 3 root of 2. So see if you notice a pattern. Side length 1, the diagonal was square root of 2. If it had side length 2, it was 2 root of 2. Side length 3, it was 3 root of 2. What if we just had a generic side length x and x? What do you think the diagonal would be? Well, as you noticed here, the diagonal is always the side length times the square root of 2. Because it was 1 root of 2, 2 root of 2, 3 root of 2. So in this case, it'd just be x root of 2. The diagonal here is always just times the square root of 2. Let's also think about the degrees on these angles here. So kind of just think about this triangle right here. We know that in a square, these are all 90 degrees, but if I cut it directly in half, if I bisect this 90-degree angle here, what is just this? Well, since it's 90 cut in half, it would be 45. And this one would also be 45. This is how we create what's called a 45-45-90 triangle. Basically just like half a square. Always imagine it like a grilled cheese, because you know, grilled cheeses are better when you cut them diagonally. So in a 45-45-90 triangle, the hypotenuse is always the leg length times the square root of 2. Here's what that looks like a little simpler. So in a 45-45-90 triangle, let's just call this a generic x. If this is x, this is also x. This is an isosceles triangle. Remember that base angles theorem where like if you have these two angles are the same, then these two sides are the same as well? It's isosceles. It's like half a square. And again, the hypotenuse is always the side length times the square root of 2, or in this case, the leg length times the square root of 2. What I mean by that is, like, let's say I had a 45, 45, 90 triangle, and the side length, 45, 45, 90. Let's say I gave you a leg length of 16. Well, then I would know this is also 16, and then this would be 16 root of 2. We're trying to get full answers here. I know that that could be a decimal, but just leave it as a radical form. Or let's say the side length was 7. That'd be 7. That'd be 7. This would be 7 root of 2. Or let's say I gave you the hypotenuse, and the hypotenuse was 9 root of 2. That would tell me that the side lengths were just 9. 9 and 9. Let's try just a couple examples here. So I notice that this is a 45, 45, 90 triangle, meaning these two legs are the same length. If that's 5, this one's 5. And then the hypotenuse is 5 root of 2, because it's always just times the square root of 2. This gets slightly more difficult, and this is as crazy as it gets, if you have to go backwards. So like if the hypotenuse is 30, how do I get back to the leg? There's a couple ways to think about this. One way is to get from this leg to the hypotenuse, I multiply by the square root of 2. So to go backwards, I'll just divide by the square root of 2. You could also just set up an equation. So I could say x times the square root of 2 equals 30. So how do I get x by itself? Well, I would divide by the square root of 2. Either way, I end up figuring out that x equals 30 divided by the square root of 2. Here's the problem. That is not simplified. So you could get a decimal out, but I'm asking you guys to leave them as radicals for now. However, radicals are not simplified if there's radicals on the bottom. You have to do what you may remember is called rationalizing the denominator. Basically, I don't want a radical on the bottom. So I'm going to need to multiply by square root of 2 and square root of 2. Here's why that helps. Square root of 2 times square root of 2 is just square root of 4, which is 2. Remember, if you ever multiply a radical by itself, it basically gets rid of the radical. Up top now, the reason I multiplied it on top and the bottom is because that keeps it balanced. This over this is technically just a 1, and if I multiply it by a 1, it doesn't change the fraction there. So on top I now have 30 square root of 2, and then 30 over 2 simplifies and just leaves 15. So 15 root of 2 is my final answer, because now I have no radical left in the denominator. So this is more simplified than this was originally. So x is 15 root of 2, and these are always the same, so y is also 15 root of 2. You can check and make sure it worked, right? Like if I take 15 root of 2 and multiply it by another square root of 2, will it give me 30? So 15 root of 2 times another root of 2. This times this is just 2, and 2 times 15 is 30. So yeah, that works. All right, rather than a square, let's now think about an equilateral triangle. What are the measures of each angle in an equilateral triangle? Well, if you have 180 in a full triangle, and you have to divide the 180 by the 3 angles, that leaves you 60 degrees for each of these angles. So 60, 60, and 60. So what happens if I split this in half? Right down the middle. First of all, what would this angle be? Well, since it got bisected, cut in half, it'd be 30 degrees. Since this came straight down, this is 90 degrees. And this is how we form something called a 30, 60, 90 triangle. Again, these just kind of pop up a lot, so we use the ratios of their sides sometimes. So 30, 60, 90 triangle. And let's think about these side lengths. So remember, this was an equilateral triangle. All of these were the same. So like, let's say this was 10 and 10 and 10. What would just this little section be? Well, since it was completely cut in half, it would be 5. Basically, whatever this is, that length is going to be double it. Or whatever this is, that length is going to be half of it. And then we're actually not going to get into this, but this right here is actually the short leg multiplied by the square root of 3. And if you want to prove that, you can, but we're not going to get into it. So basically, here's all that summarized. In a 30, 60, 90 triangle, let's call the short leg x. That's the one across from the 30-degree angle. Again, whatever that short leg is, it gets doubled when I go to the hypotenuse, because basically this is like half the side of an equilateral triangle, and that's like the full side of the equilateral triangle. If I want to go from the short leg to the long leg, you multiply by the square root of 3. So you're going to need to just memorize those, maybe make some flashcards, Quizlets, something like that. The more you practice, you'll get the hang of it. But these ratios always happen in a 30, 60, 90 triangle. So for example, let's say I had a 30, 60, 90. Just by the way, if I know that's 30 and that's 90, then this has to be 60. So there's a 30, 60, 90. Let's say this right here was 7. That's the short leg. And so the hypotenuse would be 2 times 7, 14. And the long leg would be 7 times the square root of 3, 7 root of 3. Let's say this was 50. Then this would be 100, and this would be 50 root of 3. You just plug the leg in for x, basically. Let's try just 2 more examples. By the way, if you can ever just use Pythagorean theorem, then just use Pythagorean theorem. In this case, though, I can't. I only have one side, and I need to solve for both of these. You could also do trig, so I could set up like the tangent of 60 equals 12 over x and solve for x that way, but that just takes a little longer. If you know these shortcuts, it's a lot faster, and they put this stuff on the ACT a lot. Let's start with this one. This is the short leg, and everything kind of starts from the short leg, so if you don't have the short leg to begin with, you're going to want to find that first. But in this case, I'm given the short leg, 4, because it's across from 30 here. I know that the hypotenuse is always double that, so y is 8. And I know the long leg is this times the square root of 3, so 4 times the square root of 3. It was easy enough on that one. On this one, though, it gives me the long leg, and I'm going to have to work back to find the short leg. Then once I have the short leg, I can double it to find the hypotenuse. So again, you've got to kind of work out from the short leg. So I'm going to think about, what do I normally do to get from short leg to long leg? Typically, I multiply by the square root of 3. So if I want to go backwards, I will divide by the square root of 3. Again, if you want to think of that as an equation, like take x, multiply it by the square root of 3, and you would get 12. So to get x by itself, divide by the square root of 3, and that would give you x. So same thing, however you want to think about it. Once again, this is not simplified. I can't have radicals on the bottom. It's not completely simplified. So to get rid of a radical on the bottom, you just multiply by the same thing. Do it on the top and the bottom to keep it balanced. And square root of 3 times square root of 3 is just 3. On top, I've got 12 root of 3, which does simplify because 12 over 3 is 4. The square root is its own thing. It does not get divided by the 3, just by the way. So that's x, 4 root of 3. Now to get to the hypotenuse, I just need 2 of these. I double it. Basically, it's 4 root of 3 times 2, which is just 8 root of 3. You multiply the 2 and the 4, the root of 3 stays as it is. Another way of thinking of that is if I have 4 root of 3 and then another 4 root of 3, well then I have 8 root of 3s. Or basically if you have 4 of something and it's doubled, now I have 8 of it. So regardless, that's why. Okay, you can also always test with Pythagorean theorem, make sure it works. Like would 4 squared plus all of this squared equal 8 squared, that kind of